Okay, so let's look at our first example. This is what we want to decompose into partial fractions, that original box right there. Remember I told you if you're doing partial fraction decomp, a couple things need to happen. One, the degree of your numerator needs to be less than the degree of your denominator, and that is happening here because 2 is smaller than 3. Good. The second thing before you get started is you need to factor your denominator completely. This is what I meant about they will come factored. We have not talked about how to factor this. In fact, we will not learn how to factor that until lesson 20. So I've already given it to you factored. Okay, so you don't have to go from this step to this step in the problem. I will give you the factored denominator. And I need to give you the factored denominator because depending on what this looks like, it will tell you how you set it up, right? So when we look at that denominator, we see linear factors. Everything is now showing up with an exponent of 1, and none of them are repeated, right? So we don't have any squareds going on any of these factors. So the x plus 2 gets its own term. We will have an a over x plus 2. The x plus 1 gets its own term. We will have a b over x plus 1. And the x minus 1 gets its own term. We will have a c over x minus 1. So now that we have this all set up, we will now clear out our denominators. And how we do that is I'm going to rewrite. I'm not going to write this part anymore, okay, because that doesn't really matter. I'm just going to rewrite this. I'm going to rewrite this part here. So I rewrote that so that we'll have space to go in and clear out denominators. So we're going to be multiplying everything in this equation by the common denominator. And the common denominator is x plus 2 times x plus 1 times x minus 1. So the first fraction on the left side gets multiplied by that product of x plus 2, x plus 1 times x minus 1. The fraction with the a in the numerator gets multiplied by x plus 2, x plus 1, x minus 1. The fraction with the b gets multiplied by x plus 2, x plus 1, x minus 1. And the fraction with the c gets multiplied by x plus 2, x plus 1, x minus 1. And now the next step, a bunch of things will cancel, but we need to be careful because not everything will cancel, okay? On the left side of the equation, everything should certainly cancel because I took x plus 2, x plus 2, x plus 1, x plus 1, x minus 1, x minus 1. So there's no more, nothing, everything canceled out on the left side. So all we have on the left side is 4x squared plus 3x plus 5. When we go to the fraction with the a, what will cancel? The x plus 2, because the x plus 2 in the bottom will cancel with the x plus 2 that's in the top. And it will leave us with a times x plus 1 times x minus 1. When we go on to the fraction with the b, now only the x plus 1 will cancel because b had an x plus 1 in the denominator. So b stays with an x plus 2 times an x minus 1. And then we go on to the one with the c, and the x minus 1 cancels, and we have c times x plus 2 times x plus 1. And now we have a lot of simplifying to do. I think you all will, I don't want to speak for you all, but I hope you all will find that these problems, they look very scary because there's a lot of letters and a lot of writing and things, but it's really just a lot of algebra. And good, because this class is pre-calculus algebra. So we shouldn't be surprised that we're doing algebra in an algebra class. Okay, so what I'm going to do now is start simplifying. I have to do some foiling, right? We need to FOIL this out together. When we FOIL that out together, we'll get x squared minus 1. I'm not going through all that foiling, okay? But please, if you need to do, so like I'm talking x plus x times negative 1 plus 2 times x times 2 times negative 1, and then you have to combine like terms. And do make sure that you're still using parentheses. When you FOIL that out, you will get x squared plus x plus minus 2. And then for the c term, when you FOIL that out, you will get x squared plus 3x plus 2. Okay, so now that I have that all FOILed out, I'm going to go in and distribute. So I'm keeping the left side of my equation the same. Because remember, what we're trying to do here is we want to be able to play this game that we played up here with the coefficients. right? But I can't play that game with the coefficients until I have everything all expanded out and grouped by terms, okay? Because we equate coefficients of the different terms. So distribute the a to have ax squared minus a. Distribute the b to have bx squared plus bx minus 2b. Distribute the c, cx squared plus 3cx plus 2c. And now that we have all of that expanded out, now I'm just going to rearrange some things. I'm going to put all my x squared terms together. So I have an ax squared, a bx squared, and a cx squared. I'm going to put those together. Ax squared plus bx squared plus cx squared. We also have for the x terms, we have a bx and a 3cx. I'm going to put those two terms together. So we have plus, sorry, I was looking at my notes and got distracted. Okay, so we have plus bx plus 3cx. Drop my 3. And then the last thing is the terms that don't have any variable at all. The terms with no variable, we have a minus a minus 2b, and a plus 2c. So get rid of that plus sign. Minus a minus 2b plus 2c. So now let's start grouping things together. So I had put all my x squared terms together, x squared, x squared, x squared. Let me go ahead and rewrite the left side of this equation. So with all my x squared terms together, I can pull an x squared out of those three terms, which leaves me with an a plus b plus c. Then moving on to my x terms, with my x terms together, we have a x there. I'm going to pull that x out. It leaves me with a b plus 3c. And then my constant terms, there's nothing to pull out. I'll just leave them all alone. But now what we can see is that the number in front of x squared on this side of the equation, let me stay consistent with my colors, the number in front of x squared on this side of the equation, which is 4, must be equal to the number in front of x squared on the other side of the equation, which is a plus b plus c. The number in front of x on the left side of the equation, which is 3, must be equal to the number in front of x on the right side of the equation. And then similarly, the constant term that has no variable must be equal to the constant term that has no variable there. So we're going to start equating things. So I have that 4 equals a plus b plus c. I have that 3 equals b plus 3c. And I have that 5 is equal to negative a minus 2b plus 2c. So now this looks a little bit different because this is still a system of linear equations, but this has 3 variables. Now it has a, b, and c, not just a and b. But the processes that we use to solve that is still the same. We're still thinking about the addition method, and we're still thinking about substitution. So looking at these 3 equations, I notice that I have this a and I have this negative a right there, which makes those 2 equations together a good candidate for which method? Makes it a good candidate for addition. Because if I add these 2 equations together, then I know my a will automatically cancel out. So let's see what we get. Adding those equations together, we have 9, the a cancels out. B minus 2b gives us a negative b, and then c plus 2c gives us a 3c. So now I have 9 is equal to negative b plus 3c. I can take that a step further because I have this equation right here. I'm going to write it directly under that equation, where 3 is equal to b plus 3c. Let's do the addition method again, because b is perfectly set up to cancel out once we add. 9 plus 3 gives us 12. The b cancels. 3c plus 3c is 6c. Now we can very easily solve for c. Divide both sides of this equation by 6, and we get that c is equal to 2. Once you have one of the letters it should be a lot easier at that point. A lot of things should start to fall out and become known. For instance, if C is equal to 2, we can go back to this equation and quickly find B. So we know that 3 equals B plus 3C. So 3 equals B plus, I'm going to plug in C now, which is 2. So I have 3 is equal to B plus 6. Subtract 6 from both sides of that equation, and I get that B is equal to a negative 3. Now the only thing we're missing is A. I'm just going to use that first equation. I know that, draw a line here. I know that 4 is equal to A plus B plus C. So 4 is equal to A. We already know that B is negative 3, and we know that C is 2. Combine those two, that's a negative 1. Add 1 to both sides of the equation to see that A is equal to 5. So now we know A, B, and C. So we can put all of that together to fill out this, because that is our partial fraction decomposition. Okay, so A is 5. So we have, I'm just going to write this at the top. We have 5 over x plus 2. B is negative 3. So you could put the minus sign there and then just take the 3 in the top. Or you could do plus and put the negative 3 in the top. Over x plus 1. B is over x plus 1. And then finally we have C, which we found to be 2 over x minus 1. And that is our answer for our partial fraction decomposition. I can't even see y'all's faces right now, but I'm sure there's someone out there that's not pleased, right? Because this was a lot of work, right? It's a lot of algebra. I guarantee you that when you take our test, your partial fraction decomposition problem will not be this bad. But we will look at detailed examples in the notes, and we will look at detailed examples in the classwork. Okay, I'm not going to give you a problem that's going to take 15 minutes for the test. But you might have to do something like that on the classwork, or you'll see more examples in the notes. But please don't think I'm going to give you a test problem like this, okay?